Hi, this is Ms. Schultz, and this is the practice portion of a lecture on the product rule. So take this example and take that example. Go ahead, pause the video, and you can find your U, DU, V, DV, and for both of them, and then also find the whole product, find what y prime equals for both. So go ahead, pause the video. All right, so I'm presuming you paused it. And hopefully you have dy dx at this time and dy dx over here. So u equals x to the fourth, v equals sine x. So that's 4x to the third based on the power rule, bringing that down like that. And the derivative of sine is cosine x. So when you do u dv, it becomes x to the fourth cosine x. When you do v du, I like to write the x's in front. So instead of writing sine times that, I write plus, so that's what the product rule is, u dv plus v du. So 4x cubed sine x. And that's your final answer. So that's what y prime or dy dx, whatever notation, equals. Just as a note, if this is multiple choice, you could have the equivalent answer listed. Just as a note, if this is multiple choice, you could have the equivalent answer listed of this in factored form. So they both have a common factor of x to the third. So it could appear like this. Okay. So this would be a good final answer, but you should be aware that these are both equivalent. All right, so over here, your u is x squared, and your v is 2 plus x to the fourth, which makes your du 2x. And this one looks intimidating to take the derivative of, but you just do 4 times, I'm gonna write it down here, 4 times the inside stays the same, all to the third power, and that's it, all right? You just use the power rule, 4 times your base to the third. Now, when you do it out, 4 times x squared times that, so I'll do 4x squared, I'll list it in that order, plus those two multiplied by each other, so u dv plus v du, and I'll list it as 2x, 2 plus x, all to the fourth. And that's your final answer for what y prime equals. Again, there are common factors here. If you wanted to factor it out, you'd factor out a 2x times 2 plus x to the third, and you'd get 2x plus 2x times plus 2 plus x to the first power, which would become 2x times 2 plus x to the third times 2x plus, so that's 3x plus 2. So I would list that as my final answer, but notice how I took out a common factor of 2x and then times 2 plus x all to the third power. And that's what that looked like. So dividing by that first term is 2x, and the second term, the 2x is divided to 1, and that the fourth power divided by the third power is 2x to the first power. And then I combine the like terms to do that. All right? So in this next example, you're asked to find the derivative of a specific value. So I have this function, f of theta equals theta minus pi times cosine theta, and I'm asked to find f prime of pi over 3. So take a minute, set up your product rule. So set up your u, your v, your du, and your dv. So pause the video and set that up. All right, I'm assuming you paused the video. So theta minus pi is your u, and cosine of theta is your v. Should have come up with the derivative of cosine of theta is negative sine of theta. Okay, and the derivative of this looks a little different since the variable is not x. The derivative of theta, think about what's the derivative of x. It would be 1, because it's a linear term, and so the derivative of a linear term is its coefficient. So the derivative of 1 theta is 1, and minus pi, so it's constant, the derivative of constant is 0. Okay? Now, there's two different ways to approach this specific problem for here. I'm going to do it what tends to be the most intuitive way first. So I'm going to do out the product rule, u dv, so theta minus pi times negative sine pi. You could use parentheses there or just like a multiplication sign, plus v du cosine times 1 is cosine theta. All right, so this is f prime of theta. All right, that's f prime evaluated at theta, but I don't want f prime of theta, I want f prime of pi over 3. So now, instead of evaluating at theta, I'm going to evaluate it at pi over 3. So that means I substitute in pi over 3. So go ahead, take a sec, substitute in pi over 3, simplify it all, evaluate what can be evaluated, and come up with your answer. So pause the video. All right, I'm assuming you paused, so that would be pi over 3 minus pi times negative sine pi over 3 plus cosine pi over 3. So I'm substituting it. Pi over 3 is 60 degrees. So anyway, this is negative 2/3 pi. Sine of 60 is root 3 over 2. Root 3 over 2, so I have those two multiplied with each other. Cosine of 60 is 1/2. So negative times a negative is positive. 2 square root of 3 pi, or you do 2 pi square root of 3 all over 6 plus 1/2. I would leave it like that, but if you want to get common denominators, it'd be 2 square root of 3 pi plus 3 all over 6. So either of those would be your final answer. Now, I'm going to show you what I consider to be a more efficient way. For this problem, it probably ends up being about the same amount of steps, but sometimes this technique can help you really save time. So you can substitute in when it's in this form right here. So when it's in u, du, v, dv, you can substitute in your pi over 3 right here. So u becomes pi over 3 minus pi, which is negative 2 pi over 3. Du we know is 1, all right? And then I'm gonna use this space here. V is cosine of pi over 3, and then you evaluate